We've been talking about the ancient philosophers, but now we're going to be moving towards the what's known as the modern era, which basically starts in the kind of 16th century. And one of the things that is especially remarkable about this time is the huge importance of science. So science became incredibly successful. Obviously, in ancient times, they had speculation, but they didn't have proven science. Uh, and so science became obviously the best sort of knowledge. But at the same time, things like religious belief didn't seem to fit very well with science. Although when we get to someone like Descartes, Descartes had strong belief that you could prove religious belief with a certain scientific approach. And we've seen people like Aquinas also believe that you can prove religious belief. But certainly, basically, the sort of basic methods of science seem very different from the basic approaches in religion. So it's helpful to have a background in this scientific revolution and why it was so important. One of the main figures in this scientific revolution is Galileo, and he was especially known for saying that the Earth is not the center of the universe, rather the Earth goes around the sun. And so he got into trouble for that. He was eventually put under house arrest, which is maybe not so bad, especially if you have a nice house. But he still, that wasn't so great for him. But he definitely got into trouble with the Vatican for his views. So definitely the church was a powerful force in this time, although it started to lose power over this period. And I guess it's become less powerful. So the kind of basic ideas that were developed in this scientific era, there was the idea that the Earth is not the center of the universe, rather the Earth goes around the sun. That's the heliocentric view of the heavens. There's the idea of universal gravitation. People like Aristotle had said there are two different realms. There's like the earthly realm and the heavenly realm. And there are different laws in those two different realms. But the idea of universal gravitation is that you have the same laws of science for everywhere. It's not like there are different laws of science for different parts of the universe. And obviously there was this idea of gravitation, which we may get to talk about a bit more. So then there were people like Newton and other philosophers investigating the nature of light. They started to have enough technology to create vacuums. That was quite a big thing. Then they started to investigate gases. They investigated the human body. And with the development of lenses, you could not only build telescopes, but you could also start to investigate microscopic life. So it was a very important era. There've been a lot of social changes in those times, and certainly it wasn't just the sciences. There've been changes in art, so there was a general sense that people were moving on from the earlier times, what we now call the medieval times, the Middle Ages, and they were moving on to a new era. And they were sort of moving away from people like Aristotle, and they were moving away from old approaches, and they were moving on to a whole new way of thinking. So it was sort of as a scientific time. So it had been previously that you had to just go along with whatever the church says, whatever the kind of the great philosopher says. I mean, Aristotle was revered so much, he was just referred to as the philosopher, as if there was no other philosopher or no other views worth taking seriously. And then people started to contradict those sorts of ideas. So they started to be more scientific, and like they actually did close observation of nature. And in medicine, you had people like Leonardo da Vinci doing anatomical drawings and actually kind of getting things in proportion. So art was, with ideas, developments of perspective, was being more mathematical, and that linked to developments in science. So it was a time of new technology, new math. Famously, Isaac Newton developed calculus, but there was also all sorts of other developments in math. And math was seen as being a very important way to develop new knowledge. It's certainly extremely important for the new science, but it was also important for the new art. You know, if you're developing a view perspective and how to draw a painting from a certain perspective, then math comes into it quite a lot. Now, it was a sort of curious time in that they were sort of moving away from just blind faith, but there was all sorts of ideas about kind of alchemy. One of the great goals of the era was to try and like create gold from other substances, turn other substances into gold. And that so it was on the border of magic and chemistry. So there was sort of like the birth of chemistry as a science, but it still kept a connection with a sort of a magic view of kind of being able to make one substance into another. So people like Isaac Newton were very interested in that sort of idea, and they weren't necessarily, from our perspective, totally scientific about it. The big kind of people in astronomy, there were people like Copernicus, Kepler, Galileo, and Newton. We're going to look at just a little bit more detail about how they managed to transform the whole perspective of knowledge. So this scientific revolution was not just about science. When you get new technology, you also get people building stuff and making money from it. So it was a big rise in capitalism. And it started to be the time when you had big, successful banks. It was also related to colonialism. And you had the European nations going over and colonizing other places. So it was this revolution. It was about partly expanding this worldview to all over the world. They would generally kind of see themselves as bringing civilization to the uncivilized. Now we have a more nuanced view of that, and we see there's a sort of downside in going and taking over other people. So there was all these voyages of discovery. You had new geography, new maps. All this travel brought in kind of understanding of new plants and meeting all sorts of new people and being aware of differences in culture, differences in ways of thought, and that led to kind of challenges to the question of like who's right. I mean, obviously, to a large extent, Western Europeans just assumed, well, we're right. But there were some thinkers who were a little bit more kind of thoughtful about that. Michel de Montaigne is one who was very respectful in some ways of foreign cultures and wrote very kind of thoughtfully about things like cannibalism. He said, well, you know, here we are condemning cannibalism, but like this is their culture, and we shouldn't be so judgy. We talked about the role of math. We talked previously about the golden age of Islam and how during that time they started to develop algebra and how math had been developed during that time. But the Arab scholars, that golden age ended and things became a lot more dominated by religious people who didn't tolerate views which seemed to threaten their views. So math became less of a development in the Islamic world, and Europe started to be much more successful in developing new math. So it seems like in the Arab world, they had lots of sophistication and technology, but they didn't really want to challenge the orthodox views. Another thing about math is like, it seems like a sort of simple thing, but it was very important for the development of math. In Europe, they developed the equal sign. So they started to be able to do equations, whereas Chinese and Arab mathematicians didn't develop the equal sign. So there was a kind of that, you know, it was sort of unfortunate. In some ways, you'd have thought, well, maybe they would have heard about the equal sign from what was going on in Europe, but I guess either they didn't hear about it or they didn't think it was important. Chinese culture was not a big fan of empirical investigation. They didn't think it would get get to truth, and generally in Europe was more free in this time. I mean, not totally free. I already told you about how Galileo gets into trouble with the Catholic Church, but they didn't kill him, and so there was a bit more freedom in Western Europe. So astronomy became very important, and so there was the question of like, what was the center of the universe? And obviously that's a scientific question, but it's also a question of perspective. If you think the Earth is the center of the universe, then you think the Earth is the most important place in the universe. I think we're the center of everything. It fits in with a sort of religious view that God created the world for us. If you move to the heliocentric view that the Earth is going around the sun, that sort of displaces the importance of the Earth and says we're just one planet going around the sun. That general direction of displacing the importance of humans just continued and continued and continued until like now we think that we're just one pretty insignificant planet in an insignificant star system in an insignificant galaxy. So we're just like not that important. All right, but there was this idea back then that the studying the heavens would reveal the mind of God. So there was, they thought it was very important to kind of understand the heavens. So the old view, as I've said, the geocentric view says that the Earth is the center of the universe, and the other celestial entities go around the Earth in circles. Aristotle said that, Ptolemy said that, the Christian church advocated that view, and so it's all about concentric circles with the Earth fixed at the center. And that was very much the idea that was fixed in medieval cosmology. It was an ancient thinker, Aristarchus, who first suggested maybe the Earth goes around the sun, and he'd been influenced by Philolaus, yeah, of Croton. So the idea certainly had been explored before, but nobody took it seriously. So it was really in like around the 15th century with Copernicus that the idea that the Earth goes around the sun started to be taken much more seriously. Copernicus wrote on the revolution of the heavenly spheres, and there was started to express doubt about all this medieval view. So Copernicus, he was highly educated, he was very curious. He wasn't a great scientist in terms of making accurate observations, but he had all sorts of ideas, and so this idea the Earth goes around the sun was one that he kind of entertained. So he said there is no center of all circles for heavenly bodies. The Earth is not the center of the universe. The sun is the center of the universe. And he did some math, and he tried to kind of defend this view using some observations and some math. So he sent his book to the Pope in 1530, and the Pope was like, "Oh, that sounds interesting. Yeah, go ahead and print it." And it was only 85 years later that somebody said, "Hold on, this is profoundly troubling in its heresy." By that time, Copernicus was no longer around. But then this Copernican system certainly focused on the idea of everything going around the sun in circles. And they tried to explain the motion of the planets and the sun, trying to use that kind of model. Now, you had this guy, Tycho Brahe, in the 16th century. He was Danish, and he was very good at observation. So he got much better data, and it was really his observations which made it obvious that the old geocentric view just couldn't work. Then Kepler was an assistant to Brahe near the end of the 16th century. Apparently the Danish government gave him an island where he could set up a lab, and he became the chief mathematician to the Holy Roman Emperor. So he developed a lot of data. He was very good at data collecting. Then Kepler, who had been his assistant, started to develop not just observations, but he developed laws of planetary motion, kind of talking about how we could make sense of the Earth going around the sun and the other planets going around the sun. Now, from our point of view, he wasn't necessarily totally scientific. He kind of believed in something called mathematical magic. Not totally sure what that is, but it's clearly kind of doesn't sound very scientific. But he was, one of the things about Kepler was all these previous models said that all the motion has to be circular. And Kepler says, no, it doesn't have to be circular. Things can move in ellipses. So an ellipse, as I'm sure you know, is a sort of football shape sort of outline. So he said that he found that Mars had an elliptical orbit, and then he was able to apply that to all the other planets. So then he started to try and kind of explain the motion of the planets in terms of gravity, and that's totally demolished all of Aristotle's views. So Kepler was able to kind of calculate orbits and speeds and distances. He was just really very successful with his view. And he found this law that the period of rotation and distance from the sun in the ratios the cube to the square to the cube. So he found he found math which described the motions of the planets from the sun, and so that led to a sort of harmony in the universe. Then you get Galileo, and by this stage the telescope is kind of starting to be really developed, and Galileo starts to bring in ideas of the problem of inertia. So he starts to go beyond just the motion of the planets. He's starting to think about the laws of motion. So he was a professor of math in Italy, and he was good at military engineering. So he wasn't just observing the stars, he was actually talking about the motion of cannonballs and how to aim things so you can be most effective at demolishing the enemy. But he was also good at using his telescope, and he discovered lots of stars with his telescope. He found moons around Jupiter. That was a big discovery. And his measurements are also helpful with sea navigation. So his study of these cannonballs also led him to study the motion of moving objects. He was very interested in the motion of the pendulum and how it swung, and he found a law of motion for that, the square root law. And he tried to popularize the idea that the Copernican view, that the Earth goes around the sun, is the right view. So he was jailed or under house arrest for his view. When he was doing that, he wrote another book, The Two New Sciences, which showed the path of a projectile as a parabola. So it was all getting pretty mathematical, geometrical. That leads you to Isaac Newton, who's especially famous for his development of calculus. He wrote his mathematical principles of natural philosophy, also known as the Principia, from 1684 to 86. And in some ways, he was like the total culmination of these previous scientists, Copernicus, Kepler, Galileo. And he, as I mentioned before, he developed this universal law of gravitation. So the idea is that there's just one set of laws of science. They apply to the whole universe. You don't have to talk about two different realms. And so that was completely throwing out Aristotle's ideas. He developed his three famous laws of motion, and it led to a very mechanistic view of the world. The idea that the world is like a machine and it operates according to laws of motion. So he was English. He had a fairly solitary childhood. He was around the time of the plague in 1665. He didn't catch the plague, and instead he was in lockdown. I guess he was lucky because his lockdown was good for him. He actually made a lot of discoveries during his lockdown in his solitude in his country home. So there were other people around the time of Galileo, and you may have heard of some of these people. We'll be looking at some of them. So there was Gottfried Leibniz, Nicholas Mercator. We'll be spending a fair amount of time looking at René Descartes, who was, he lived to the age of 54, died in 1650. Then there was Fermat, Blaise Pascal. So these were all people who worked in math, but also worked in philosophy. They did all sorts of geometry. So it was just like an incredible time for science, a massive flowering of science. Calculus was especially important in science, and the mathematicians in the Golden Age of Islam had talked about ideas of infinitesimals, but Newton is the one who really made it kind of formal and developed this whole notation for calculus, which was able to him to be able to do these calculations. So his idea, his whole approach was very sophisticated and allowed him to be able to calculate the area under a curve, which you may remember doing if you've done calculus. At one point, he was probably the only person who could do that. He was influenced by Galileo, and he was very interested in the pendulums, and that led him to the idea of centrifugal force, and that led him to the idea that gravity holds planets in place. There was a lot of debate about the nature of gravity, and it's a pretty interesting idea. He also did optics, and so he put light through prisms and made a spectrum, and so that led to the idea that white light is a combination of all the different colors. But it also, he came up with the idea that light is more like a projectile, and so light bounces off things. Previously, people had this idea, which sort of makes some kind of sense, that we saw by projecting something out of our eyes and then kind of getting it back. So this idea that light came from the human eye to the object observed. I mean, it seems like an odd claim, because it would, if that was right, then it seems like people's eyes would be like little flashlights. Obviously, they're not. So it seems like a strange sort of theory, and certainly it became abandoned with this new study of light. So it led to a more sophisticated views of perception, and we're going to talk a lot about perception and what we understand about the world, both with Descartes and Locke, and then with Hume. So the reason why all this science is so important is it led to a total change in our understanding of the world. And it led to this model of kind of scientific thought as being like the model for how to understand the world. And so rather than just having all these speculations that previous philosophers had, for previous philosophers, there wasn't really any distinction between science and philosophy. It was all just a lot of speculation. This new science made a kind of more profound distinction between speculation and real science. And it said, like, well, I know if you really want to understand the world, you have to observe and you have to do experiments. There was a whole new way of thinking about reality, and kind of led to the kind of modern the valuing of scientific inquiry. So it led to kind of more skepticism about people's claims. It led to a mechanistic worldview, and it led to a lot of philosophers having a kind of very new views of the world. All right, so that's what I got to say about the scientific revolution.